Let's see how we can create dynamic SQL queries with Spring Data JPA. We will use a small demo bookshop. The main entity class is book. We also have format, category, language, and author classes. Now, in a real-world bookshop application, we will have multiple filters that users apply to find the book they need. But we don't want to write separate queries for various combinations of these filters, right? And this is where dynamic SQL queries come into play. As the name suggests, they enable us to create SQL queries dynamically based on the user input. To build dynamic queries with JPA, we can use the specification interface. It can help us build multiple predicates over the entity. These predicates can be combined to create queries with flexible where clauses. To make use of JPA specification, let's make our book repository interface extend the JPA specification executor. Now, let's create a book specification class where we will define custom specifications for the book entity. Let's start with the category filter. First, we check the input for null or blank. This is the skip the filter if input is empty part. So, if the user sends nothing, the method decides no category filter should be applied. Specification.unrestricted returns a neutral specification. Spring Data JPA's current API defines Specification.unrestricted as the neutral does not participate specification. It behaves like a spec that contributes nothing to the final query. Think of it as much everything, do not add a where condition here. That is useful for dynamic filtering, where some request parameters are optional. Now, let's build a query condition. A specification book is a function that Spring Data JPA calls when it needs to build a SQL query. This function receives three things: root, query, and CB or criteria builder. It returns a predicate. Root represents the entity being queried, here book. CB is a criteria builder. This is the JPA object used to create query conditions called predicates. In our case, we are building an equality condition. Note that our Lambda has root, query, and criteria builder, but we only use root and criteria builder. This is totally fine because a query is needed in case you want to modify the overall query. For example, you want to set distinct, add fat joins, or inspect result type. But for simple equality predicate, you do not need it. So here it is just part of the required specification method signature. Note that we have passed the field names as string. This is fragile. If somebody changes the names of the fields, you will get nasty runtime errors. To avoid that, I propose using the JPA Static Metamodel generator to create type-safe queries. Yes, type safety is actually possible with JPA. All you need is to add the Hibernate processor to the Maven compiler plugin. Then run Maven clean compile. The metamodel will be generated in the target directory under generated resources. And here's a snippet of it. Now we can use the metamodel in our book specification class. Let's rewrite the hasCategoryName method. Root get book category accepts book underscore. Book underscore is a generated metamodel class. It contains typed references to fields of book. So instead of using strings, you use book underscore category, which is checked at compile time. It is important because if somebody renames book category to book category, for example, the string-based code still compiles and fails later at runtime. Metamodel-based code fails at compile time immediately. Okay, great. Let's create other filters. They are created in a very similar way. Let's create a filter for language, format, and price. And of course, you can create as many filters as you like. Finally, let's create one more method called withFilters. That method is a composer. It does not create a new kind of predicate itself, but it takes several smaller specification book objects and combines them into one final specification. As a result, it builds one specification that applies all provided filters together. Specification.allOf takes multiple specifications and combines them into one specification using logical AND. The empty filters are simply ignored. This is thanks to Specification.unrestricted that we added to each filter method. Now let's create a book service class to use this logic. Create a findAllFilters method in the service class where we pass all our filters as parameters. It will fetch books using the filters the caller provided. What happens here? The method receives 4 optional filter values: category, language, format, and maximum price. It calls book specification with filters to build one combined JPA specification book. It passes that specification to book repository find_all method. Spring Data JPA turns that spec into a SQL query and returns the matching book rows. Great, this is it. Let's create some tests to verify that our code works as desired. I'm using the data SQL file populated with test data. You can find it in the repo of this demo project. This is where the expected numbers are coming from. As I'm using H2 database for this simple demo, no test containers for spinning up the database container are needed. Only Spring Boot test annotation. This is how we create type-safe dynamic SQL queries with Spring Data JPA. If this video was useful to you, don't forget to like it, subscribe to our channel, and until next time!